Good morning. Today we will discuss X-rays, its production, its properties, and its spectra. X-rays are discovered by Röntgen in 1895 during some experiment with the discharge tube. He was actually performing some other experiment not specific for X-rays. So that's why these rays were called X-rays. Why these rays are called X-rays? Answer is, when Röntgen performed his experiment with discharge tube, he noticed that when opaque material were placed between the tube and the screen, the intensity of light decreased but did not appear. He noticed that some unknown radiations were given out and called them X-rays. So that's why these rays were called X-rays. He studied these rays in details after completing his experiment of discharge tube. Now, what is the mechanism of production? The X-rays are produced by bombardment of fast-moving electrons on solid target. The target is generally with high mass number. The tubes through which cathode rays are discharged are of two types. First one is Röntgen tube, that is old tube, and second one is Cooley's tube, that is modern tube. Now, variety of tubes have been developed depending upon the requirement, like diagnosis in medical science, X-ray therapy, crystallography, radiography, etc. There are so many other fields in which X-rays are used. So first of all, I will discuss Röntgen tube, then Cooley's tube. So what is the difference between these two tubes? In first case, the cathode is on the left hand side, as you see in the figure, and anode is placed along on the right hand side, as you see in the figure. At anode, there is a target with high mass number element, and negative charge is given to the C, positive charge given to anode. When electron beam, that is cathode rays, are striking on the anode, that is target, then X-rays are produced. The voltage applied for production of X-rays is in the range of 10 power 3 to 10 raised power 5 volt. That is very high voltage. So this is a Röntgen tube. And second one is Cooley's tube or modern tube. In this tube, the most part is same as that of Röntgen tube, but there is step-up transformer is connected instead of direct supply. This step-up transformer is used to control the quality as well as intensity of X-rays produced. The remaining structure and voltage is same. Now, the properties of X-rays. First one, the wavelength of X-rays varying from 0.01 angstrom to 10 angstrom. And second one, X-rays have high penetrating power. Third one, the X-rays are classified into two categories. First one, hard rays, that is high energy and small wavelength. And second one, soft X-rays, low energy and larger wavelength, lambda. And fourth property, it causes fluorescence. Fifth one is, it ionizes the gas through which it passes. And fifth one, it affects the photographic plate. And next, they travel in a straight line. The velocity of X-rays is equal to the velocity of light. And X-rays are absorbed by the material through which they pass or they travel. They show interference and diffraction. That is, generally we studied X-ray diffraction, XRD. And last one, effect on the human bodies. As we know, X-rays are harmful for human body because it destroys living tissues. Redness on the skin is appeared when person is exposed to X-rays, and there are surface sores, and these rays kill white corpuscles, that is WBCs, in the blood, and it may develop into gangrene. But these problems are appeared or can be seen only when we use for exposure for a long time, that is prolonged exposure. Next one, application of X-ray. So first of all, I will discuss X-ray diffraction only. So X-ray diffraction, it is also called Bragg's law. So we know that we have already studied these X-rays or Bragg's law in lower classes also. We know that when incident beam, that is X-ray beam, is incident on the crystal, this is the crystal, having the atoms are placed at fixed distance, the interatomic distance is d. When this beam is striking on the atoms, then it reflected in this direction. The angle of incidence or angle of reflection, these are theta and theta, as shown in the figure. When we draw perpendicular from A to N1 and A to N2, then there is a path difference of N1B and BN2 between two rays. This path difference is very important because by this path difference, we will try to prove Bragg's law. If we study this right angle triangle ABN1 and ABN2, then it is observed that Bn1 is equal to d sine theta and Bn2 is equal to d sine theta because both triangles are similar triangles. So total path difference is Bn1 plus Bn2, that is d sine theta and d sine theta, that is 2d sine theta is equal to delta. Delta means path difference. Also, we have already known for constructive interference, because in the case of interference of light, this condition has already described. Delta is equal to n lambda. If we compare the path difference obtained from this law and path difference for the constructive interference, then we will get a result 2d sine theta is equal to n lambda. So this is called Bragg's law. So X-ray diffraction, that is XRD studies, are used to find crystal structure and properties of atom in the molecules or in the matter. Thank you very much.